All right, let's be honest. Have you ever been sitting there watching an apt upgrade on your encrypted Kali VM and just wanted to throw your entire laptop out the window? If that sounds familiar, you are in exactly the right place. In this explainer, we are going to fix that I/O lag for good. And here's the best part, we're not going to sacrifice any security to do it.
I mean, this quote just nails it, right? Encryption is supposed to be your seatbelt, a silent guardian that just works. But when your VM grinds to a halt, it feels exactly like this, a giant, clumsy parachute getting in the way of everything you're trying to do. It's not supposed to be a straitjacket.
Now, if you go online, the internet's favorite answer is always, just disable LUKS encryption. But come on, that's a terrible trade-off. We're going to show you that the real performance bottleneck, the thing that's actually slowing you down, almost never lives where you think it does. It's hiding somewhere else entirely. So, how do we finally ditch this parachute? Well, first things first, we stop guessing and we start measuring. We have to find the real bottleneck. Because adding more CPU cores to a disk I/O problem, that's kind of like trying to fix a flat tire by putting more gas in the tank. It just doesn't work.
You know that feeling, right? That vibe that your machine is just slow? Well, that feeling is a symptom. It's not a diagnosis. To get to the root cause, we need cold, hard data. And the single most important piece of data for this is a little something called I/O weight.
To put it really simply, if your VM is lagging but your CPU usage looks low, it means your processor is literally just sitting there twiddling its thumbs, waiting for the disk to catch up. A high I/O weight percentage is the smoking gun. It proves, without a doubt, that your bottleneck is the storage path.
Okay, so now that we know the problem is with the disk, we can finally go after the number one suspect, encryption. But, as we're about to see, LUSK, that's the standard Linux disk encryption system, is very often wrongly accused. Now, this is a really crucial point. You have to understand that there are two totally different costs to encryption. The first is the unlock cost. That's the one-time delay when you type in your password at boot. But the second one, the runtime cost, is the tiny bit of overhead for every single read and write while you're using it. And that's where everyone thinks the problem is.
So here's the big reveal. That painfully slow apt update or that lagging burp suite project, it is almost never because the AES encryption algorithm itself is too slow for your CPU. Nope, it's because the virtual storage stack, all those software layers between your Kali OS and your actual physical hard drive, is misconfigured and causing a massive traffic jam. So if it's not the encryption, then what is it? Okay, let's get to the good stuff, the fixes. And we're not going to be fiddling with a bunch of minor settings here. We are going to pull the three biggest, most impactful levers you have for massive performance gains.
That's right, just three. The solution really boils down to just three key settings inside VirtualBox. If you focus on these, you can solve the vast majority of I/O bottlenecks without ever touching your disk encryption.
Your first, and honestly your most powerful lever, is the virtual storage controller. You can think of this setting as the traffic cop for your VM's disk requests. It decides how all those operations are queued up, managed, and sent down to your host machine. Changing this can have an absolutely massive impact.
And here's the key takeaway from this. Think about what a Kali workload looks like. It's tons and tons of small, random file writes. Well, the NVMe controller, which is the modern standard for high-speed storage, is built for exactly that kind of traffic. Just switching from the older SATA controller to NVMe can make a night and day difference. All right, next up is the Use Host I/O Cache setting in VirtualBox. This little checkbox is a perfect example of what I call a caching paradox. It can either be your VM's best friend, smoothing everything out, or it can be its worst enemy, causing it to freeze and stutter like crazy. So what this setting does is it tells VirtualBox whether to use your main computer's memory, your RAM, to buffer disk operations for the VM. When you get it right for your workload, it absorbs all those sudden bursts of writes beautifully. But when you get it wrong, you get these flush storms, where the whole VM just pauses, completely unresponsive, while it waits for that cache to sync up with the disk. And finally, lever number 3. We have to talk about the slow trap of dynamically allocated disks. I know, they seem super convenient when you first set up your VM, right? They only take up as much space as they need. But that convenience comes with a hidden performance tax that you pay over time. And this is the result. This is what it feels like. As that dynamic disk grows, the actual file on your host computer gets more and more fragmented. Performance just slowly degrades over weeks and months until your VM becomes totally uncooperative. It's not a sudden failure, it's a slow decay, all caused by this disk type.
So we've covered the big 3 wins. Now let's just quickly go over a few common mistakes and hidden problems that can completely undermine all your hard work. Think of this as the please don't do this section.
Before you even think about tweaking a single VirtualBox setting, you have to check for a right storm inside your VM. If some background process, like the system swapping memory to disk or a browser just constantly writing cache files, is just hammering your virtual disk, well, it doesn't matter how well-tuned your settings are. You have to quiet that storm first.
Seriously, just learn from my past mistakes here and save yourself a whole weekend of frustration. Throwing more RAM or more CPU cores at a disk queue problem will not fix it. Messing with your Lux password settings is not going to make apt any faster. And most importantly, please, don't change 5 things at once. You'll have no idea what actually worked. All right, let's put all this theory into practice. Here is a simple, repeatable plan that you can run through in the next 15 minutes to go from being annoyed and confused to being measured and totally in control of your VM's performance.
This is how you move from guessing to knowing. Step 1. Measure. Establish a baseline. Run a real task like an apt upgrade and use a tool like IOStat to watch that % IO weight number. That's your starting point. Step 2. Change only one thing, like switching the storage controller to NVMe. Step 3. Retest. Run the exact same task again. Now you have hard data, actual proof that your fix worked.
So, by focusing on the virtual storage stack instead of just blaming encryption, you get to have it all, security and speed. You don't have to compromise. So now that your VM is fast and it's secure, the only question left is, what are you going to build with it?